And welcome everybody to the Saturday night edition. And welcome everybody to the Saturday night edition of the Daily Space Weather Show. We've got the fresh imagery that you might have come to expect from the channel coming at you from the Smash News Network. Least busted name in news. Congratulations on realizing the channel exists. This is November 24th and November 25th to date from SDO. And shall we zoom in a little bit closer? It is indeed the house favorite wavelength. And we've been known to change things up a little bit. Here is 335 angstroms as well. Same time frame. 335 is good at showing active regions, coronal holes, and filaments. We'll also show 304 angstroms, which is good at showing solar flares, filaments, and active regions. And we do have some activity going on here. Looks like some CMEs in the past 24 hours. We'll cover it. And a brief look at sunspots before we talk about things like sunspot numbers. There is the current situation. We have about 185 sunspots. And there's colorized magnetogram for the same period, November 24th and November 25th to date. That's not half bad. And by the way, if you enjoy the content, make sure you press the like button. Thanks to our new subscribers on YouTube, by the way. Congratulations on realizing the channel exists. I'll say it again. I'll say it probably countless times. Make sure you press like. If you're new to the channel, press subscribe. Get the world's most comprehensive daily space weather delivered to your subscription feed. We've got geomagnetic storm conditions going on, by the way, and they look like they're going to continue at least through the next update. KP6, a G2 level geomagnetic storm, caused by a long duration coronal mass ejection impact. We'll talk about solar wind data here momentarily, right after you've pressed like, because until you do that, the video cannot continue. The following are paid advertisements from the channel. Please visit the links below the video. Become a member of the Smash Team if you want additional content. Smashomash.com/Smash Team. It's our own subscription services site. Similar to Patreon, only better. There's a bronze level, there's a silver level, there's a gold level, there's even a gold annual paid-up subscription. If you want additional content, smashomash.com/Smash Team. If you want to buy a book, buy it through our Amazon shop. Another paid endorsement is our Amazon shop, amazon.com/shop/smashomash. Today's featured product is Shaolin White Crane. Learn from Dwingming Yang about Shaolin White Crane with the handsomely bound Shaolin White Crane book. The first about 80 pages are about general Kung Fu stuff, and the rest is specifically about the northern art of Shaolin White Crane, a long to medium range based Shaolin Kung Fu style. Also, you can find our Hemp Lucid shop. If you shop at hemplucid.com, don't forget to enter the promo code SMASHOMASH10. SMASHOMASH10. It'll save you 10% on checkout. You can also visit our link below this very video. There's also a link on the homepage to our paid affiliate Hemp Lucid. SMASHOMASH10 is the promo code to use to save as many percent. Today's featured product from Redbubble is some advanced trolling. Yes. So the featured product is the Croissant Earth Society. What, are you some kind of what, do you believe in NASA's lies? Do you think Earth is shaped like an oblate spheroid? What, are you crazy? Some people out there claiming Earth is shaped like a pizza. I mean, come on, folks. Everybody that watches our channel is well aware that Earth is shaped like the French breakfast pastry. Croissant Earth Society. Either join it or live in darkness, believing the lies of NASA. Croissant Earth Society, delivering mankind from the ignorance wrought upon them by the National Aeronautics and Satanism Association. SmashOmash.com is where you can find all of our links, more or less. So help us out with clicks if you're unable or unwilling to open your cobweb-encrusted wallet, and send us a few bucks per month by joining the Smash team. Visit us on social media, press share, etc., press like, tell your friends and foes. Thanks to everybody who has. Once again, thanks to our new YouTube subscribers. Thanks most of all to the Smash team for increasing the likelihood these videos will continue to exist, remain publicly visible, and free for all to view. Volcanoes, Popocatépetl not observed. I don't know. Looks like Iceland's not erupting either. Let's move on to earthquakes. There are the past 90 days, and yeah, that's what's been going on. And these are the quakes of a 5 or greater magnitude for the past some period of time. The past 24 hours is what it should show. And indeed it does. So let's scroll up the list here. So near New Guinea, Papua New Guinea, there was a 5.1 that was at 4:48 this morning. Northern Mariana Islands, lots of activity going on up there. Could be a foreshock. Is there a large earthquake about to happen in the Western Pacific? Let us know in the comments what you think. What else we got? The Peru-Ecuador border region had a 5.1 there. In northwestern South America, Northern Mariana Islands also had a 5.5. Again, it looks like there could be a larger event fixing to happen there, folks. Is it a foreshock, a series of foreshocks? There's a 5.6 at the Northern Mariana Islands, right adjacent to the deepest trench in the ocean, the Marianas Trench. And let's continue on, as there is plenty more to cover. So the 10.7 centimeter radial flux is now at 179, I think, 176. 176 is the 10.7 centimeter radio flux. There's the 1-year chart. It's got to be updated, I think, but it's close right up here. 176 is the F107. And it looks like, indeed, there is some geomagnetic storm forecasted for late in the day tomorrow. So there you go. Geomagnetic storm conditions likely to continue here. Corona hole high-speed stream on the way, likely to arrive sometime earlier in the day tomorrow. So we could see just a passing of the baton there from coronal hole high-speed stream to coronal hole high-speed stream from coronal mass ejection. So what we're seeing right now is a CME, a coronal mass ejection impact. Aurora likely in many spots. We'll get to it. First, the last 4 hours of Earth's magnetic moment from space. That's what things are likely looking like. From the perspective of magnetohydrodynamic pressure. So the sun would be off to your left here, and this is the time of a geomagnetic storm. So it is a G2 geomagnetic storm. KP6 is the planetary K index. And again, it is likely to stay at KP6 for the next update. By the way, if you want to see if the aurora are likely where you're located, one of the places to do it is the ground magnetic perturbations map. So these are the past 4 hours of Earth's magnetic moment from the ground, and there may be a lot of people in the U.S. able to see the aurora right now. So that's our line of sight. That's our ground magnetic perturbations map there. Geospace Delta B ground magnetic perturbations for North America. Remember, folks, if you think you can see the aurora, make sure you go out and use your camera. Most of the aurora is ultraviolet light and hence not visible to the naked eye. So here's also the full globe view, and you can see many areas where there are the possibility of aurora even at very low latitudes. So we've been showing it on the map for years. There's a prime example of a KP6, a G2 class geomagnetic storm in action. That's the past 4 hours. Earth's magnetic moment from the ground. Again, it's likely for KP6 to continue here. We haven't seen the solar wind letting up yet. And before we move on to anything like that, let's show another way to see the likelihood of seeing the aurora. This is the geoelectric field map, so it's showing actual induction into the power grid here. It's literally showing you voltage per kilometer. So that is super useful. If you see this light up, it might be time to go outside and check it out. If you've got clear skies, this can tell you when the aurora might be visible in your location. The aurora comes and goes rapidly, so the more real-time your data can be, the more useful it is for your aurora chasing capabilities. So there you go. KP6 is the current situation. A geomagnetic storm for quite a long duration here. Staying in geomagnetic storm conditions throughout most of the day today, starting around 9 o'clock this morning, and only increasing in intensity. And there's the data from ACE. We'll show the most recent signal there. A little under 600 kilometers per second for the solar wind speed. Here's Discover. It's a little bit more of a complete record. About 13 protons per cubic centimeter at about 550 kilometers per second for the solar wind speed. So it looks like the storm is going to let up. If these conditions persist here, the field is dropping off. So I think this is subsiding. Coronal hole high-speed stream is next, so by midday tomorrow, expect to see a big uptick in the solar wind density once again. So a well-defined coronal hole has some high-speed wind on the way. So space weather ends and rapidly again begins. Here is the GOES magnetometer, the GOES 16 and the GOES 18, I should say. And there you can see those geomagnetic storm conditions. A bunch of stuff waving back and forth there in the magnetosphere. The GOES magnetometers are located in the outer portion of the outer Van Allen belt. And the GOES 16 and GOES 18 are near equatorial geosynchronous satellites. Next is our top view ecliptic plane field plot. Oh, it's so good. So that's what's going on in the heliosphere. Earth is still in a North Pole sector. There you can see the magnetism. We'll also show the line of sight field plot. Again, Earth is remaining in a North Pole current sheet, a North Pole sector. We also like to show the ecliptic plane field plot, line of sight style. And look at all the magnetic organization in the photosphere level shown in grayscale. That is a lot of magnetic organization. Last but not least, our line of sight coronal hole plot. And we'll stop that on the last image before we move to coronal holes in SDO. So there's SDO 211 angstroms. Let's zoom out to 100% zoom. So basically what's going on right now is these are north and these are south. So sector boundary crossing is pretty close by there. Yeah, so those are south. These are south over here. So that's the coronal hole situation. Moving to sunspots. Sunspot number about 182, 183, something like that. 182, I'll say, according to Rob, the Royal Observatory of Belgium. And here's our probability monitor for flares. We still do have a significant possibility for M or even X-class events. Right as that massive sunspot group faces the Earth, here's the current probability. So number 11 there, showing some magnetic organization as well. 40% chance of an X-class flare there from Sunspot 3500. So Sunspot 3500. Also, we've got 3501 got a name there. Also 3502 got a name up here. So those do explain the increase in the sunspot number since yesterday. And here come sunspots in SDO Continuum. Once again, that is November 24th and 25th to date. Mostly stable there. High likelihood of large solar flares continues during this geomagnetic storm and solar flare watch. It's exciting times for space weather, and we ain't even at solar maximum yet. Just ain't there yet, folks. Ain't there yet. We've also got 171 plus colorized magnetogram for you. Just a classic combo view there from the SDO Browse data features. And let's move on to energetic particles and solar flares. No spikes in the proton flux. High likelihood to see a spike in the proton flux with the very high likelihood of solar flares. And CMEs, actually. So don't be surprised to see a spike in the proton flux. X-ray flux here, only one X-class flare throughout the last 48 hours. Only one M-class event, and it was a small M-class event. Sunspot's a little bit underperforming once again as the sun withholds plasma. El Sol, are you holding out? Are you holding out, El Sol, Helios? Here's 94 angstroms. And there are remaining a series of massive plasma filaments on that local yellow dwarf. That's 94 angstroms, November 24th and November 25th to date. And that most recent M-class flare did come from this sunspot down here. So we'll be keeping an eye on especially this sunspot, which is showing some extreme magnetic complexity. Also this massive group. The two most likely places to see large solar flares. So that's the scenario. Here's a star chart from skyandtelescope.org. That's what's going on overhead. The moon and Jupiter close by in tonight's sky. If you see a bright light near the moon, it's the third and sometimes fourth brightest object. Jupiter, known as Zeus to the ancient Greeks. Next, a solar system forecast. That's where things are today. Here's your 1 week forecast for heavenly bodies. That's where things will be in 7 days. On the 2nd December, as this year is getting short, folks. Almost in December already. Where did the time go? Today's astronomy photo of the day is a crazy panoramic photo featuring northern lights and some crazy 3D imagery, and it's not really it is the Earth, but it's a thing that's done by that dude there whose name is at the place, Victor Lima, apod.nasa.gov. If you'd like to check it out on your own, it's a bunch of stuff. The Pleiades and Jupiter also featured on that image. Anyway, moving on to CMEs, as it's time to see if any more CMEs are headed our direction. So here are yesterday's images, and we showed most of this on yesterday's video, except the last couple of hours, so nothing new there on those 95 frames from November 24th. Here are 93 more frames from today. And what do we got? Anything earthly directed? Let us know if you're crossing your fingers or hiding in a bunker. I don't suspect those are earthly directed, but let's continue to look here. Here's LASCO C2 and C3. So there was an event just after noon that popped off out of the northeast. Here's another view. Let's bring this back to speed things up a little bit. Just after noon here, we see something popping off in the northeast. Also the southeast, a little bit of ejecta there at the same time. We'll also show stereo A. Here's a location of stereo A, our friendly neighborhood roving coronagraph. So here are yesterday's images. Here's today. Chronograph on the left and difference imagery on the right. So we do expect to see 2 CMEs there out of the northeast and, well, just generally in the east. And there it looks like a bunch of missing data there on the raw imagery. What about the... There it is. At least it shows up on the difference imagery. And it looks like it got hit with some relativistic particles there. Well, that's interesting. But is it earthly directed? Let's take a look at one more thing. All right, so here's 193 angstroms by itself. And around midday, we should see something headed toward Earth. Okay, there could be earthly directed components in that latest CME. So there could be another one about to strike Earth here sometime late in the day on the 28th. We see that CME came from this area right here. That is somewhat in the earthly directed zone there, folks. So that could be another earthly directed CME. Now multiple are on the way. So see our previous daily space weather videos for our previous forecasts. Another CME likely to arrive late in the day on the 28th. The 28th of November, another CME impact in the forecast. Again, it came from right up here. And while most of the ejecta will miss to the east, some likely to hit the Earth. Good times. Anyway, moving on to filaments. And first we'll start at the Lermonth, Australia today. The Lermonth, Australia ground-based National Solar Observatory Hydrogen Alpha Telescope. There you go. A bunch of large, very dense plasma filaments on the Earth-facing portion of the solar disk. We also like to show the grayscale imagery. What happened? There you go. It does show prominences, and we are seeing a prominence down in the southeast, so perhaps another new sunspot about to rise there, and possibly 2 more active regions likely to rise in the east. So we're seeing prominences up here, prominence down here. So as many as 3 new sunspots have the possibility to rise in the next day or so. So there you go. And before we get the bonus features, let's take a look at thanking all of our viewers who've joined us over on Twitter. Yeah, x.com/smashomash. Thanks to everybody who's tolerated the pathetic censorship on social media in general and is able to actually see the videos. And of course, if you didn't see yesterday's Daily Space Weather video, you might have missed the Ask a Particle Physicist segment. So make sure you check that out if you haven't. Make sure you subscribe to Eugene the Philosopher. And before we close out the regularly scheduled space weather segment, move to bonus features. There are the past few hours from that is the GOES 18 SUVI, and here come bonus features. Let's blast through them. Satellite charging hazards. We have some surface charging over the Middle East. There you go. Some low energy electrons building up on the outside of spacecraft there. Surface charging hazards north of the equator. GOES electron flux here. Kind of low levels, as you may have come to expect. Probably erroneous levels as a result of the ionosphere puffing up because of a geomagnetic storm. That is a normal thing. Read the tabs down here if you're not familiar with the GOES electron flux data. Tells you all about it. There's the 1-year graph of the relativistic electrons. That's from solon.info if you're wondering. Let's make sure that's refreshed. And it is. There's the NOAA forecast for relativistic electrons. And it looks like expecting a dip. I would tend to agree, as there is a coronal hole high-speed stream on the way. So that'll change things. Next, the actual data on that. Let's move on to the Bureau of Australia, the Bureau of Meteorology of Government Australia data. There it is, the ionosphere. In megahertz, and especially toward the end of this, you might see a lot of low-frequency anomalies. Here's anomaly in megahertz from a 30-day median. You'll see a lot of red lighting up here as the video progresses, as we have seen the strongest geomagnetic storm just in the past few hours, KP6. There you see a lot of low-frequency anomalies there showing up toward the end. No surprises there to our regular viewers. Anyway, there is the latest 2315 Universal Time ionosonde, and there is 2315 Universal Time anomalygram. Also the whole atmosphere model, or WHAM. Total electron content on the left, maximum usable radio frequency on the right. And you might expect a low total electron content, but that's not really what happens. The ionosphere gets puffy. And the electron flux is measured using radiography. So the GOES are trying to measure at 300 kilometers of altitude, and when the ionosphere puffs up, those electrons aren't at the same level. So that's how the reading becomes erroneous on the GOES electron flux during geomagnetic storm conditions. So that's what's going on. Geomagnetic storm. Next, total electron content by itself. Feel free to pause the video on this frame if you're not familiar with distances in miles. There is the CTIPE, the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. It's free electrons from the inner portion of the outer Van Allen belt down to ground level. And no, Kim Jong-un did not create those electrons. Next, the total electron content anomaly of the 10-day average. The anomaly from the 10-day average over North America. We are seeing some rather high electron contents, making it likely for some significant GPS errors at perhaps unexpected times. Over the western continent. We'll close out space weather with the latest. There you go. There's the magnetogram. And there is the intensitygram. It looks like we have some new sunspots forming way over there on the western limb. So it looks like another uptick for sunspots coming in the next 24 hours. And it's time to go to meteorology. Meteorology segment starting out with space weather. Yeah, nullschool.net. It shows space weather. You can bring up space. It'll show you the likely place to see the aurora. There you go. Just press now and click space, and you'll see where the aurora most likely. Here comes your weather forecast for all you aurora chasers especially. There are the surface winds of the east. There are the jet streams of the east. There are larger views of the central world, jet streams, central world's surface winds. Windy times in the eastern Mediterranean. There are the surface winds of the west. And let's don't forget the jet streams of the Americas. There you have it. Next, clouds and fog. If you're wondering if you'll be able to see the aurora, this map should help. Clouds and fog over North and South America. And next, let's show snow forecast. So there's a snow forecast for the next 3 days on the Euro model. Here's the GFS model. Canada getting lots of snow, but especially Kansas getting some pretty heavy snow there, some significant accumulation there over Kansas. Both of the forecasts, Euro and GFS, agree. Next, our weather.gov map, weather.gov. We've got some hard freeze warnings in California and a bunch of winter weather warnings in Kansas. No surprise there. Here come some forecasts from Tropical Tidbits, tropicaltidbits.com. Go give them props over on Twitter or something. Here's your 72-hour GFS pressure and precipitation forecast. Large pressure gradients continuing over the Rockies. Apparently not enough hot air coming out of Colorado to dissipate all of those huge barometric pressure gradients. Next, total accumulated positive snow depth change in inches. And it looks like some areas of Kansas there likely to see over 6 inches. Well over 4 inches at least. It's a GFS model for 72 hours for snowfall. Next, our lightning map. That's the past about 10 hours. And here's a real-time lightning map showing the past 1 hour. Yeah, 1 hour. And here's me vanishing because I'm breaking through the screen. My head is melted by keying. Got some lightning there north of the Mediterranean. And here comes our U.S. Doppler radar map. We can show you the full 50 state. We'll focus on the lower 48. So there you go. Here is clouds and fog for the lower 48 once again. Let us know if you see the aurora. Share it with us over on Twitter, x.com/smashomash. There's water vapor map. Clear skies over Arizona and New Mexico for the most part. Here's your recap. Vertical motion in the air column depicted by U.S. Doppler radar map. Ground-based systems detecting vertical motion of things like ice crystals. Clouds and fog depicted by infrared radiation satellite. 3.9 micrometers is the band. And there is 6.19 micrometers infrared radiation, showing water vapor as in all of it. And here's me closing out because it's getting very late and we got to get this onto your screen. So thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Whoa!